Hello, welcome back. So, what do we mean by when we say the corners of a circle? So, we saw in one of our last examples when we're trying to find extrema on a surface. If we have a circle of radius 4, a cylinder basically of radius 4, being projected to some surface, f of xy, and if that radius is 4 right here, we're going to project it. And we were looking to find the absolute maximum, the absolute minimum on this surface. So what we need to do, because this is multivariable, the first thing we're going to check is our critical points. The second we check are the edges, and both of those are pretty easy to solve for. The third one, because it's a circle, we have to look for the corners. And what I want to talk about in this video specifically is how we find, what do we mean when we say the corners of a circle? So recall, what we're going to do is we want to project this surface, this circle, this cylinder in 3 dimensions into our surface, our function f of xy. To do this, we would solve if we want to think of the circle on the xy plane, if I were to solve for x squared, I would get x squared equals 16 minus y squared. Now remember, we would plug that in to our equation. So recall, we're gonna when we looked at the edges, we would plug this into whatever our surface is, and that would give us our edges. But to get the corners, we think of the circle, if we look at the xy plane, we got to recall, this is actually 2 equations right here. We really get x equals plus or minus the square root of 16 minus y squared. As a result, this is going to form 2 halves of a circle, both centered at 0, 2 halves of a circle. And if we notice, the top and bottom, we got to think of these independently from each other. If we look at the top and bottom, it's not considered differentiable by any calculus standard. And you might think, well, why isn't it? Well, because, remember, the derivative does not exist at an endpoint. So these are considered endpoints. So my first corners would occur, in this case, where where y would be plus or minus 4. And that's because if I think of this on the xy plane, these would be my corners, and they would occur at 4 because that's my radius, plus or minus 4. Now, if we were to look at the other way, so there's 2 of my corners. So my first corner would be 0, 4, and 0, negative 4. Those would be my first 2 corners. Now, what if I did the other way? Say y squared equals 16 minus x squared. Well, again, this is going to give us the 2 equations. Y equals plus or minus the square root of 16 minus x squared. And again, if I think of the xy plane, this is going to give me 2 halves of a circle, like so. But in this case, the endpoints are on the x-axis. And again, these are considered endpoints because these are not differentiable at this point. So here, the corners, what we say, would occur at plus or minus x equals plus or minus 4. So our new corners here would be negative 4, 0, and 4, 0 as well. Now, most people aren't going to remember this. You're not going to remember this. Nobody remembers it. Nobody ever remembers it. So what we're going to think about, when you think about the corners of a circle, so what we're going to think is the quadrantals. If I draw my circle, radius 4, I am thinking of only the quadrantals. These are where my corners occur of my circle. So there's 4 of them that we got to kind of remember. I hope this video helps. If not, give me a thumbs up. Just kidding. All right. Like and subscribe. Talk to you later. Nope. Oh, wrong button. Nope. Wrong button again.